Question 6 looks like this, and it is slightly different to the questions we've previously been seeing. Why is it slightly different? It's got a radius and a tangent here. The question tells us that AT is a tangent. However, this line is not a tangent. It passes through the circle. The question doesn't say it's a tangent. What that means is we cannot assume that this radius is 90 degrees to the tangent. It is not, because it's not a tangent. This is just a line. So what can we do? Well, what angle are we trying to find? We want to find OBT. So we want to find that angle, this entire angle here. We can find part of that angle already because A to B to T lies inside of a triangle where we've already got two of the angles. So this part of the angle will be angles in a triangle add to 180, so 180 minus 41 minus 58, and that is going to give us 81 degrees. So we've found part of that angle. Now, because this is a tangent, the angle between this radius and this tangent is 90 degrees, which means that this little angle here is 90 minus this 58. So it's going to be 32 degrees. And this triangle OBAO is again an isosceles triangle. It's got two sides which are the radius of the circle. So this little angle here must also be 32 degrees because it's base angles of an isosceles triangle. Which means this full red angle is the blue angle plus the purple angle. So it would be this 32 plus this 81. So angle OBT is going to be equal to 32 plus 81. So that gives us an answer of 113 degrees. Question 7 is a little bit different because there are no numerical angles on the diagram. The question wants us to prove that angle BMN, so this angle here, is half of y. We're going to approach it as though it's exactly the same as any of the other questions. So what can I do first? The only angle I've got is this angle y here, but it is within a triangle where two sides are the radius. So this and this, they are the same, which means these two angles are going to be the same. Now, what is the size of those two angles? It's going to be 180 because that's angles in a triangle. We're going to subtract y. That would give us these two added together. Because these two are base angles of an isosceles triangle, they equal the same, so both of them are half of this. So we want this divided by 2. That's going to give us 180 divided by 2, 90, minus y over 2, so half of y. So this angle here is 90 minus a half y. This is a tangent and this is the radius, so this is 90. So this orange angle, 90 minus a half y, plus this red angle must make 90 degrees. The only way for that to be the case, we've got 90 minus a half y, we need to then plus a half y to make that work. Let me just mute my computer, apologies. The other way we could do it is we could say that 90 minus a half y plus angle BMN equals 90. So this 90 minus a half y here, plus this angle BMN, must equal 90 degrees because it is the angle between a radius and a tangent. And if we rearrange this, I'm going to do that over here. Take 90 away from both sides, so this goes and this goes. That leaves us with minus a half y plus that angle BMN now equals 0 because we've subtracted 90 from both sides. So then if we just move this half y, if we add half y to both sides, I'm going to get rid of it here because I've added half y on. And then 0 plus a half y gives me a half y. So that angle BMN is a half y. Question 8 is similar to question 7 in that we are working with non-numerical angles. The question wants us to prove that ACB, so this angle, is 90 minus x. It wants us to prove that, so we can't assume it in the first place. We need to do a load of maths that's going to show that this ends up being 90 minus x. So if I'm breaking this question down for myself, I'm thinking about what type of question is it? It's a circle theorems question. So I would like to get a circle theorem in there if at all possible. It's not a quadrilaterals question, so I'm not going to just find these two angles and then find this one from 360. I'm going to need to, I might do that, but I'm going to need to use some circle theorems along the way. I can't use that this is 90 degrees because it isn't. This is not the radius, this is a tangent. But it might be useful to add in some radii so that I can use that property. So this is now a radius, this is a tangent, so this is 90 degrees. This is a radius, this is a tangent, so this is 90 degrees. I have made this look like a straight line, that's just my terrible drawing. So it is not a straight line. However, this is now a quadrilateral, which means that this angle, this angle, this angle, and this angle add to 180. So we've got 90 plus 90, sorry, not 180, 360. 360, Miss Sturgis. This angle, this angle, this angle, and this angle add to 360 because it is a quadrilateral, not a triangle. So this plus this plus this plus this, 360. I can take 180 away from that because these are both 90. So this one plus this one equals 180, which makes this angle 180 minus 2x. This angle here is at the centre. I'm going to try and make those a bit straighter because they're so terrible. There you go. How's that? A bit better? Lovely. So this angle is subtended from these 2 points and it's at the centre. This angle is subtended from the same 2 points and it's at the circumference, which means this angle is twice as big as this angle. So this angle here, which I'm going to call Z, is equal to this angle halved. So half of 180 minus 2x. If I multiply that out, I get 90 minus x, which is exactly what the question wanted. For question 9, I have not got the materials with me to do a really accurate drawing, sorry, so I'm just going to run you through the method. It says construct the graph of x squared plus y squared equals 16. Now this is the equation of a circle. Because it's x squared, not x minus something all squared, that means the x coordinate of the centre is 0. Similarly, the y coordinate of the centre is 0. So the circle sits perfectly centred on the set of axes. This number here is the radius squared. So the radius of the circle is the square root of this, which is 4. So we would draw a circle. Its centre is at 0, 0. Its radius is 4. So it crosses the x-axis at 4. It also crosses the y-axis at 4. It crosses the x-axis again, 4 away from the centre, but obviously it's in the negative direction, so that's at -4, and this is also at -4. So that's the first part. The second part wants you to find estimates for the solutions of the simultaneous equations this and y equals 2x plus 1. The way it wants you to do that is to now draw this line onto the same graph and then estimate where they are crossing. So 2x plus 1, that is going to cross the y-axis at 1 and the x-axis at -0.5. So you would draw a straight line through those 2 points. And then the solutions of these simultaneous equations are where they're equal. Now obviously I don't have an don't have the measurements on my graph, so I can't read off the values, but you would read these values off. You would read off the y coordinate and the x coordinate of this point. You would read off the x coordinate and the y coordinate of this point, and those 2 points would give you your solutions to those simultaneous equations. Question 10 is finding the equation of a tangent to a circle. So we've got a circle here. It has radius 5. It is centred at 0, 0. If I had to write down the equation of this circle, it is x squared plus y squared equals 25. We've got a point on the circumference of the circle, point P, and that also lies on a tangent to the circle, and it's this tangent that we want to find the equation of. So it's just equation of a straight line. A straight line has the equation y equals mx plus c. So we want to find an equation for this line that is y equals the gradient times x plus some constant. We do not have enough information about this straight line to find the gradient or the constant either. However, if we add in the radius of the circle, this radius of the circle is perpendicular to the tangent. This is 90 degrees here. So I can find the gradient of this radius first of all. So that's what I'm going to do. So I'm going to do gradient of radius. It goes through the origin, so it goes through 0, 0. And the gradient is change in y, so 3 minus 0, over change in x, so 4 minus 0. So it is 3/4. So that is the gradient of the radius. I do not need to work out the equation of the radius, just the gradient is fine, because from there I can get the gradient of this tangent. Because the radius and the tangent are perpendicular, the gradient of the tangent is the negative reciprocal. So I flip the fraction and I make it negative. And there is the gradient of the tangent. So I now know that the tangent has equation y equals -4/3, that is m, times x, plus some constant. Still need to find what this constant is, and I can do that by plugging in this point. This point lies on the tangent, so it has to satisfy this equation. So I'm going to plug that in. Y is 3 equals -4/3 times x, which is 4, plus some constant. That means 3 is -16/3 plus some constant. So we get if you use your calculators, that this constant is 25 over 3. So that means then that this equation of our gradient is the, equation of our tangent is the gradient times x, so negative 4 over 3 times x, plus the intercept or the constant, which is 25 over 3. So this is the equation of the tangent. Finally, question 11 looks much more difficult than it is. If you draw a diagram for this, it instantly makes it much simpler. So it says the line L is a tangent to the circle x squared plus y squared equals 40. So I'm going to draw that on. X squared plus y squared, there's no x minus a, y minus b, so it's centred at the origin. So we've got a circle centred at the origin. Now if we've got x squared plus y squared equals 40, that is the radius squared. So the radius is the square root of 40. It's the square root of 4 times the square root of 10. So it is 2 root 10. So the radius is 2 root 10. This point here is 2 root 10. This point here is 2 root 10. This is negative 2 root 10. And this is negative 2 root 10. Now it tells us that the line L is a tangent to the circle at point A, and point A is 2, 6, so roughly here, say. So this is A, 2, 6. I'm going to get rid of this bit now. And the tangent to this, L, crosses the x-axis at point P. So I'm going to draw the tangent on. We've got point P there. The question wants us to find the area of the triangle O, that's the origin, A, P. So it wants us to find the area of that triangle. To find the area of a triangle, we do the base times the height. We've already got the height, the vertical height. It is 6 because it goes up to point A, which is 2, 6. That's the y coordinate, so that is the position on the y-axis, so the height is 6. We need to find this length here. To find that length there, all we need to find is this point P. And to find that point P, if we find the equation of this tangent, we will be able to work that out. So it is just the same as the last question. Because we're now only working in this quadrant, I'm going to get rid of some of this so I can do some working on the rest of the board. So to find the equation of this tangent, I'm going to do the same as I did last time. I need to find the gradient of this tangent, which is the negative reciprocal of the gradient of the radius. So the gradient of the radius is going to be change in y, 6 minus 0, over change in x, 2 minus 0. So 6 over 2, so it is 3. Which means that the gradient of the tangent is going to be the negative reciprocal, so it's going to be negative 1 over 3. That means our equation of the tangent is y equals negative 1 over 3x, so that's the gradient, plus some constant. I'm going to find what that constant is by plugging in this point. So y is 6 equals negative 1/3 times x, which is 2, so negative 2/3 plus some constant. And that will give us that the constant is 20 over 3. You should be able to get that from your calculators. So make sure you can work that out to be 20 over 3. So the equation then of this tangent is y equals negative a third of x plus 20 over 3. To find this point P lies on the tangent and it crosses the x-axis, which means that the y-coordinate at this point is 0. So this is something 0, and we can find what that something is by using our equation of the tangent. So y is 0. We don't know what x is, we want to find it. So y is 0 equals negative a third of whatever this x coordinate is plus 20 over 3. Rearrange this equation. We've got negative 20 over 3 equals negative a third x. So x must be 20. What we've now got then is just a triangle where this base is 20 because it goes from 0 to 20 on the x-axis, and this height is 6. So I'm going to get rid of everything else now. You can pause it and have a look at it if you need to work through it, and then we'll just work out the area of this triangle. So you can actually get rid of pretty much everything else on the board. So I've got a triangle of height 6 and base is 20. So the area of the triangle is simply going to be half times base times height. So that should be 60 units squared. Okay, so that is all of the questions on that topic test. If you still don't understand some of them, please let me know. Comment on Show My Homework, let me know what you're struggling with, and I will try to explain it in a more detailed way.